All right, looking between these two, we're seeing that there's a squared for one of them and a square root for the other. Is there anything else you notice? What'd you say? The line's going up and the line's going kind of to the side, right? Okay, good. Anything with the table?
Yeah.
What'd you notice? Yeah, they're flip-flop, right? All right, ready? But today we're going to talk about inverse functions, so including notation using quadratic and square root functions, and verify that inverses are by composition. Okay, so if f of x, and this is what we this is notation that we use for inverse. You see there's like little -1 up at the top. This is the inverse of f of x. Okay, if they're inverse functions, these characteristics will be true. Okay, the first thing that'll be true is that the inverse function and f of x are going to reflect over the line y equals x. Do you remember back in geometry where you had a reflection across the line y equals x? Do you remember what the rule was for that reflection? I know it's been a really long time. Do you remember what that rule was? It looked a lot like this line. And what I mean by that is the rule was switch your x and y. Yeah. So just like we noticed in the activating strategy, you see this -2, 3. Well, the inverse is going to be the opposite of that. Nobody's surprised by this. Great. Awesome. Okay. Yep. Like the table? They might give you an equation and they might give you a graph. It just kind of depends on the problem. But if they give you like an equation, you can just plug it into Desmos and then pull up this table. You can do it that way if you wanted to. Talking to me? Okay. All right, so looking at this next one, what do you notice about this function and this inverse? Okay. The dotted line. So why is there this dotted line? Well, there's a hole in the graph, not a hole in the graph. We make a big deal out of things being functions, okay? If we use the vertical line test, that means that we draw a straight line, roughly straight, straight up and down. Does it pass through 1 or 2 points? Passes through how many points? Just 1, right? And we could do that at any point. If we drew a line over here, how many points is going to pass through? So this guy is not a function. That's what they're wanting you to know. Okay, so vertical line test tells us if a function or not. Okay, vertical line test tells us if excellent. Based on your learning so far, predict the equation, table, and the graph of this thing. Okay, so we just learned what about the table? If they're inverses, they're going to do what to the table? You're going to switch them, right? Okay, so what we're going to do is write this y column and this x column, and then this x column and this y column. So we're just going to write straight down. Okay, so all I did was I took the y column, put it as the x column, put it as a y. Okay, so now we're going to graph all these. Okay, remember we always start at 0, 0. We go the x value, either right or left, and then up or down with the y value. So we go to the left 8, down 2. So left 1, down 1. 0, 0. 1, 1, and 8, 2. All right, connect all those dots. Writing the equation. When you do the inverse function, what you're actually going to do, what's good? I don't know. I can look it up in a second. I don't know off the top of my head though. Right. Okay. So in order to get the equation for this, we're going to take the original function. We have y equals x to the third. And what we're going to do is we're going to switch our x and y and then solve for y. Okay, so watch the magic. So we're going to switch our x and y. So it's going to be x equals y to the third. And now we're going to get y by itself. So how do we get rid of this cube? What do we do? Not square root. What is it? Cube root. Okay. All right. So then that gives us y equals the cubic root of x. Yay. What? The cubic root? Yeah. Right, so to compose two functions means substituting one function into the other. Okay. So what we're going to do is we're going to take f of x and plug g of x into it. You know, have y'all ever seen the movie Shrek? Like you all seen the movie Shrek, right? It's real funny. And he's like, onions have layers, ogres have layers. It's kind of like an onion. Okay, and what I mean by that is we're kind of just like peeling back parts of it. So we've got the function f right here, which is 3x plus 2. And we're going to take g of x and substitute it in for this x. So we're going to plug in for x that g of x. So that's going to give me x plus 5. So now I'm going to distribute. And that's going to give me 3x plus 15 plus 2. That's going to give me 3x plus 17. So that's f of g of x. That's what they have right here. Now, we're going to do it the other way where we list out g and then plug in f in for x. Okay? When we simplify that down, we're going to get 3x plus 7. Okay? Everybody understands what we're doing there. Let's take a look at the next slide. So, composition of inverses. So, when you compose a function and its inverse, the operations always are going to leave you with an x. Okay, so for instance, they give us this example of x squared and the square root of x. We're trying to see if these are actually inverses of each other. So we're going to plug in square root of x inside x squared. So I'm going to show you what that looks like. So I'm going to take x squared and plug this in for that x. So square root of x, and we're going to square it. What would that simplify down to? Just x, right? Then we're going to do it the other way. We're going to take the square root of x, and we're going to plug in x squared. Well, what would that simplify down to? Just x. So if that's the case, then these are inverses of each other. So you're going to take the composition, do it, and if you get x at the end, then that is the inverse of each other. Okay, so when you do the composition of a function and its inverse, the operations always cancel out and leave you with an x. So we're going to verify that g of x and inverse of g of x are inverses by finding the composition of each. So we're going to first do g of the inverse of g. So we're going to write out g first. And we're going to take the inverse and we're going to plug it in for x. So we're going to rewrite this. And we're going to plug in the cubic root of x minus 4. Seku, if y'all don't stop talking. When I simplify this down, -4 and 4 are going to cancel. And I'm going to get the cubic root of x raised to the third. Well, these are going to cancel out. So that gives me x. So it works over here. I'm going to do the same thing, but first I'm going to start with the inverse, and then I'm going to plug in the original function. So I'm going to plug in the inverse, or I'm going to write that one out. And so I'm going to plug in v of x. So x plus 4 cubed, and we're taking the cubic root, and then we're subtracting 4. So the cubic root of something to the third power is going to cancel. I'm going to get x plus 4, and then minus 4. 4 minus 4 is going to cancel. This gives me x. So again, this also works. Resume. Okay, so let's go ahead and check it out on this one. So we get y equals square root of x minus 2. And then we also are going to have y equals negative square root of x minus 2. Okay, is that a reflection across that line? When you kind of like tilt your head to the side, is it a reflection? Yes. Okay. All right. So we got this line right here, and it's a straight line. Unfortunately for us, it's linear, right? Okay, so what is the equation of this line? So back in the day, in Algebra 1, you had y equals mx plus b, right? What's your y-intercept? Where's across the y-axis? That's 3. Okay. And then what's the slope? Well, from this point to this point, we went up 1 and over 1. So this is going to be 1x. So we got y equals 1x plus 3. Now, if we're trying to find the inverse of something, what are we going to do with the x and the y? Okay, so switch the x and y. So we have this. Now we want to solve for y. So we're going to subtract 3. And so x minus 3 is going to be the inverse. Say again? Or about No, she's covering another class. So you're good. Okay, so we're going to have the inverse function is going to be x minus 3. Okay, so let's check our work. Y equals x minus 3. Oh, I'm sorry. This is not checking it. So on this next one, what is going to be the equation for the inverse function? I want you to take a moment, try to find. So switch your x and y from this function, and then solve for y. Take a second, try this one. Okay, so we got y equals x to the third plus 3. So what's the first thing we're going to do when we find the inverse? We're going to switch the x and y. And now we want to get y by itself. So what are we going to do? So we switched our x and y. Now what are we going to do? We're going to solve. Again. Okay, subtract 3 from both sides. And so it's going to give me x minus 3 equals y to the third. We get this third power. How do we get rid of a third power? Take the cubic root. Yay. Okay, so the cubic root of x minus 3 equals y. And now we're going to graph that. Remember, when you're graphing this, use this little keyboard, go to function, go all the way down to the bottom, and that button in the middle is going to be how you're going to type that cubic root. And look, ta-da!
Look, see, look, even she said that.
That's pretty good. That's pretty good. Okay, go ahead and skip to slide 12 and slide 13. Oh, go ahead and go to slide 13. Go ahead and find the equation of this. Okay, go ahead and find the equation of this one. Okay, if I have this function, I want to find the inverse algebraically. What am I going to do first? Switch my x and y. Now what? Okay. So I'm going to add 2. And then how do I get rid of this cube? Cubic root. So then we're going to have the cubic root of x plus 2 equals y. Whenever you write the inverse function, you always want to leave the little -1 up at the top. All right, so we have this function. What are we going to do first? Switch my x and y. And then now we want to get y by itself, but it's already attached to the squared, right? So how do we get rid of a squared? The square root. Okay. So we're going to take the square root. When you take the square root, you're going to have a positive and negative. All right, so now what do? Move the 4 to the other side by adding. So this is now going to be square root of x plus 4. We're also going to have a positive and negative version, and it's equal to 3y. So now what do? That was real specific. Divide by 3 on both sides. Okay, so that's going to be plus minus the square root of x plus 4 divided by 3. Okay, sometimes these problems seem a little bit complicated. Not too bad. And again, you can always check by graphing them, or you can substitute them into each other to find the composition. Okay. Okay, so just a reminder, Delta Math is due on the 27th. So I'm going to give you some time to work on it in class. There is also one on solving radicals that is going to be due next, I think it's Wednesday. I think it's February 1st. And then there's going to be one on this inverses. It's going to be only like 4 questions long though. It's not going to be long. So go ahead and take a moment. Go ahead and locate Delta Math and go ahead and get started on that.